Hi everyone, this is Unit 2 review. So looking at number 1, answer the following questions about the graph below. What is the domain? Well, the domain of all polynomial functions is all real numbers, so that is negative infinity to positive infinity. The range, we see that it's going down forever and it's going up forever, so therefore it is also all real numbers, negative infinity to positive infinity. The number of turning points, so that is counting the total number of maximums and minimums. So that would be 1, 2, 3, 4. So there are 4 turning points. The possible degree based on turning points, so remember we take the number of turning points and we add 1 to it to get a possible degree, which would be 5. And that makes sense because my ends are going in different directions. If they were going in the same direction, it would need to be even. But this case, it's an odd number. 5 is odd. They're going in different directions, so that is reasonable. Looking at letter E, how many relative minimums are there? Well, that's how many low points there are. There is one right here and one right here. So there are 2 relative minimums. How many relative maximums? That would be here and here. So there's also 2 relative maximums. State the zeros and their multiplicities if it's even or odd. And if their multiplicities are even or odd. Okay, so here we go. I'm going to start with my first 0 on the left side. That is at -1. -1 would have an even multiplicity because it is bouncing off the x-axis. So x equals -1 has an even multiplicity. Looking at the next one, that would be +1. It is also bouncing off the x-axis. So x equals +1 is also an even multiplicity. And last but not least, +3, x equals 3. X equals 3 is crossing the x-axis, which means it has an odd multiplicity. So even multiplicities bounce off or are tangent to the x-axis. Odd multiplicities cross through the x-axis. Now we're going to do end behavior. As x approaches negative infinity, f of x approaches. Well, negative infinity is the left side of the graph, so that is this piece. So as my x goes towards negative infinity, my y value also goes down towards negative infinity. As x approaches positive infinity, f of x approaches, well, positive infinity is the right side of the graph. I think I said the right side for the first one. I'm sorry, I meant the left side. Okay, so as x approaches positive infinity, that is the right side of the graph, f of x is going up, which means it's approaching positive infinity. So my left end behavior is as x approaches negative infinity, and it goes down towards negative infinity. As x approaches positive infinity is my right side, and it's going up towards positive infinity. Okay, number 2, describe the end behavior for the following polynomial functions. So this is using the leading coefficient test that we need to identify the degree, whether our degree is even or odd, and then our leading coefficient if it's positive or negative. So looking at letter A, I look for the highest exponent to determine the degree. The highest exponent in this polynomial is an 8. 8 is an even degree. So my degree is 8 and it's even. I know even functions go in the same direction, so they're either both going up or they're both going down. Now I look at the leading coefficient. The leading coefficient is attached to the highest degree, so that would be the -5. So my leading coefficient, I'm going to abbreviate it LC, is -5, which means it's negative. Okay, so since it's negative, that means my right side needs to be going down, and because it's even, that also means my left side is going down. So this is my end behavior. So since both sides are going down, as x approaches negative infinity, f of x is also approaching negative infinity. As x approaches positive infinity, f of x is, or y is also approaching negative infinity because they are both going down. And that's it. Moving on to part B. First thing we got to do is identify our degree. So we look for the highest exponent. That is 9. So my degree is 9. Then we look for the leading coefficient. The leading coefficient is the number attached in front of the variable with the highest exponent. So my leading coefficient is -4, which is again negative. So because my degree is odd, I forgot to say that, because my degree is odd, I have two options. It can be going up and down or down and up. Okay, so either one of these. Because my leading coefficient is negative, that means the right side has to go down. The right side has to go down. So that would be this one right here. So my end behavior, as x goes towards positive or negative infinity, that's this side, my y is going up towards positive infinity. As x goes towards positive infinity, my y, this side right here, is going down towards negative infinity. So this is the chart from the leading coefficient test. Looking at number 3, solve the polynomial inequality and identify the correct solution set. Then graph the solution on the number line. So number 3, first thing we have to ask ourselves is it set equal to 0? In this case, it is not. So first, we're going to make sure that it gets set equal to 0. So that starts by adding 4 to both sides. So I add 4 to both sides. I get 3x squared minus 7x plus 4 is less than 0. Now I'm going to go ahead and type this into my calculator. Okay, so we are going to graph this in our calculator. So go ahead and take out your calculator, turn it on, get a new document. No, you do not want to save. And you're going to add a new graph. Add a new graph. So we're going to graph that function that we just have. Okay, that we have where it's on one side and 0 is on the other. So we have, 3, it's never a good spot for this, 3x minus 7. I'm going to have to keep switching it back. So 7x plus 4. Okay, you don't have to worry about the inequality sign, and it should be a 3x squared. So make sure it's a 3x squared minus 7x plus 4. Okay, what we are looking for is when the y values are less than 0. Less than 0. Since it's less than 0 and there's no or equal to, we can automatically eliminate anything that has brackets. So now we're down to a 50-50 chance. So when it's less than 0, that means it's going to be below the x-axis. Below the x-axis. So I'm going to go ahead and graph it. Okay, I get something that looks like this. I need to know the zeros so I know where it's below the x-axis. So we're going to hit menu 5, 1. Menu, trace, graph trace. Menu 5, 1. So I get my first 0 at 1, 0. I get my second 0 at 1.33. Okay. Now I see I have 4/3, so I'm assuming 4/3 is 1.33. Okay. I want it below the x-axis. Well, below the x-axis is between 1 and 4/3, or 1 and 1.33. So that would leave me with answer choice A. Okay, it is above the x-axis from negative infinity to 1 and then 4/3 to infinity. That would be if it was greater than 0, but this is less than 0. So now we need to graph this on a number line. So let's graph it on a number line. We start by putting our zeros or our critical points on there. We have 1, we have 4/3, which is the same thing as 1.33 that we got on our calculator. So we need to graph. Because there's no line, we have an open circle. Because there's no line, we have an open circle. And we want to shade the area between 1 and 4/3, which is this right here. And that is it. That's our answer. Going on to the next part, B, we have x squared minus 12 is less than x. So we are going to start by making sure that we have our whole polynomial on one side and 0 on the other, which means we need to subtract x from both sides. So I get an x squared minus x minus 12 because there's no like terms, which is less than 0. So what I need to do now is I need to graph my polynomial function right here, and I need to see what is less than 0. So again, this is less than 0, which means I'm looking for stuff that is below the x-axis. Okay, since it's also less than, again, I can eliminate anything with brackets because less than goes with parentheses. So I can eliminate answer choice B and answer choice D. So now again, I have a 50-50 chance. So let's go ahead and go to our graph. So we're going to start with, I'm going to hit the home button. I'm going to get a new document. No, we don't want to save, and we want to add a graph. So we're going to go ahead and graph what we have. We have x squared minus x. Was it minus 12? Yes, minus 12. We graph, enter. We want to find our zeros. So menu 5, 1, menu 5, 1. And we're going to use our left and right arrows to get to our zeros. So I'm using mine right there. My first 0 is at 4. My second 0 is at -3. I want what is below the x-axis, so that goes from -3 to +4. So I go back to my answer choices. That would be answer choice A. So now we're going to graph that answer choice again on our number line. So we're going to plot our zeros. We have -3. We have 4. They both get open circles because there is no line underneath the inequality sign. And we're going to shade in the middle because that is the solution set. And that would be it for solving polynomial inequalities. If the polynomial said greater than, then we would look for the pieces that are above the x-axis. Okay, going on to the next one. A fireworks rocket is launched from a hill above a lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by g of x. How long will it take the rocket to hit the lake? Well, think about it. If it's starting on the ground and we want to know when it hits the lake again, or when it starts at the lake and it wants to hit the ground, we're looking for the zeros. So what we're going to do on this one is we're going to graph this equation right here. We're going to look for its zeros. So we're going to graph, and then again, it's menu 5, 1. So let's go ahead and graph it. So I'm going to start with a new document. No, we don't want to save. We're going to add a graph. We had -16x squared plus 64x plus 80. So plus 64x plus 80. Press enter. So we want the 0. If we're talking about time, then we do not want a -0. So we have a -0 that we do not want. We only want the +0. That tells us when it hits the lake. So we're going to go menu 5, 1. It starts me at my y-intercept, so I need to move to the right. And it's going to take a little bit of time, so it's okay. So we're going to keep going to the right, to the right, to the right, okay, until the word 0 pops up, and it tells us 5, 0. Which means it took 5 seconds for the rocket to hit the lake, or the firework to hit the lake. That is our answer. So it will take the rocket 5 seconds to hit the lake. Okay, next one. A rock is thrown from a top of a building. The distance in feet between the rock and the ground x seconds after it is thrown is given by f of x. How long will it take the rock to hit the ground? So we're going to do the exact same thing that we did on number 4. Okay, we are going to take our function that we're given. We're going to graph it. We're going to look for menu 5-1 and look for the zeros. Again, we only want the positive zeros because we are talking about time and we cannot have negative time. So we have negative 16x squared minus 4x. So new or home, new document. No, we don't want to save. Add a new graph. So we have negative 16x squared plus 4x minus 4x plus 382. So let me fix my sign. So negative 16x squared minus 4x plus 382. Okay, I graph it. I'm going to hit menu 5-1, menu 5-1, menu trace, graph trace. Again, I want the positive, so I'm going to move to the right side. And I get 4.76. This 4e to the negative 10th is basically saying that we would move the decimal place after the 4 11 times to the left, which basically gives us 0. So our answer is 4.76. It will take 4.76 seconds for the rock to hit the ground. Again, we do not want that negative 0 because we cannot have negative time. Okay, number 6, find all the zeros of the given polynomials. So again, we're going to graph what we have, menu 5-1, find each of the zeros. So here we go. I'm going to go back to my calculator. I'm going to go home, new document. No, we don't want to save. Add a graph. Add a graph. We have 2x to the 5th. Plus 7x to the 4th plus 7x to the 3rd plus 2x squared. Enter. We have 1, 2, 3, 4, 5 zeros possibly. Okay, so let's see. 1, 2. Well, we're just going to hit menu 5-1 and let it do all the work for us. So I'm going to go ahead and start over here and work my way left to right. So my first 0 is negative 2. Okay, so from negative 2, hit that right arrow until you get all the way to the next 0. So we have negative 2, negative 1. Keep going. Negative 1/2. So let's go ahead and write those before I forget them. So we have our zeros so far as negative 2, negative 1, negative 0.5. Let's see. Keep going, keep going, keep going. And we have 0, 0, and that looks like it's it because 0 has a multiplicity of 2 because it is bouncing off the x-axis. All the other zeros have a multiplicity of 1 or an even or odd multiplicity because they're crossing. So -2, -1, and -0.5 have an odd multiplicity because they are crossing the x-axis, and 0 has an even multiplicity because it is bouncing. Now, if we think about it, if I have -2 has 1, -1 has 1, and -0.5 has 1 as a multiplicity, that means 0 has a multiplicity of 2 because my degree is 5, and my zeros can match my degree. Okay, so that's just a little extra information that you may need for the test. So my zeros are -2, -1, -0.5, and 0. Now we are going to do the same thing, but with a new polynomial equation. So we're going to graph, home, new document. No, you don't want to save. We're going to add a graph. We're going to graph 5x to the 4th minus 47x squared plus 18. We graph. So it looks like it's crossing 4 times. I need to find all 4 zeros. So menu 5, 1. It always starts us at our y-intercept. So we're going to have to move to the left. I'm going to move to the left until I get to that most outside zero. So there we go. We get -3. Then I'm going to go back to the right. So we have -3. And right there is a 0. So that is -0.632. So let's go ahead and write that down because I will forget it. So -0.632. And we had over here -3. Okay. So far we have our zeros as -3, -0.632. Okay, let's go ahead and find the last two. So we're going to continue using that right arrow. Did I pass it? There I did. Okay, so now I have a positive 0.632. Okay, and then I'm going to keep going until I get to that last one, which is a positive 3. So we have a positive 0.632 and a positive 3. So this one had 4 zeros, and notice that the degree of this polynomial is 4. Okay, so again, you can find these by graphing. Number 7, there's 2 options. You can graph these or you can do it by hand. I have shown you several times how to graph and use the calculator to find their zeros. Just remember that an even or a multiplicity that's even bounces and a multiplicity that's odd crosses. This one I'm going to show you how to do by hand. So we're going to take each individual factor and set it equal to 0 in order to find them. Find the 0, and the exponent is their multiplicity. Now notice, this 3/4 is just a number. It has no x attached to it, so we can disregard it right now. But if you look at answer choice B, or example B or question B, this has an x, so you would have to set that equal to 0. So when it has an x, you set it equal to 0. When it does not, you can disregard it. Okay, so first one, we have x minus 2 equals 0. I add 2 to both sides. I get x equals 2. So this has x equals 2 with a multiplicity of whatever its exponent is, which is 4. Now we move on to the next one. We have x plus 6, so we set that equal to 0. And I subtract 6 from both sides, and I get x equals -6. And its exponent is 1, so it is x equals 6 with a multiplicity of 1. Moving on to the next one, we have x minus 14 equals 0. I add 14 to both sides. I get x equals 14. Its exponent is the multiplicity, which is 3. So we get x equals 14, multiplicity of 3. And that would be our answer for this question right here. Okay, again, you could graph it, find the zeros. You would just have to be able to identify the multiplicity. Okay, next one, we have h of x. So again, each individual piece. So I have this piece, I have this piece, I have this piece, and this piece right here. So each part is going to be set equal to 0. So I have 6x squared equals 0. I divide both sides by 6. I still get x squared equals 0. I take the square root of both sides. X is still equal to 0. So I have x equals 0, multiplicity of its exponent, which is 2. Then I go to the next one, x minus 8 equals 0. I add 8 to both sides. I get x equals 8. Oh, yeah, 8. And I look at its exponent, which is 2. So I have x equals 8, multiplicity of 2. I go to the next one. I get x minus 19. I set it equal to 0. I add 19 to both sides. I add 19 to both sides. We get x equals 19. So x equals 19, and its multiplicity is its exponent. And its exponent is 6, so it has a multiplicity of 6. Looking at my next one and my last one, I get x plus 2 equals 0. I subtract 2 from both sides. I get x equals negative 2. It has an exponent of 1, which means its multiplicity is 1. So x equals negative 2, multiplicity of 1. And that would be all of the zeros and their multiplicities. Okay, well, that's not going to work for me there, so I'm just going to highlight it for us like that. Okay, next one, use the rational roots theorem to list all the possible rational zeros for the given functions. So this is one that you cannot use a calculator unless you need it for the factors of the number. Okay, so here we go. I have, remember, P over Q. P is all the factors of your constant. Q is all the factors of your leading coefficient. So my constant is the number without a variable, which is 60. So I need to find everything I can that multiplies to give me 60. Every number I can that multiplies to give me 60. So I'm going to show you how you can use your calculator to find these factors. So what we're going to do is we're going to go to our calculator. We're going to add a new graph. Okay, and I have a new graph, and we're going to type in 60 divided by x. 60 divided by x. So whatever number we want to find the factors of, divided by x. Okay, and we're going to press enter. We don't care what the graph looks like. We just want to look at the table. So you're going to hit on your calculator Control, which is the yellow button, and the letter T for table. T for table. Okay, or you can go to Menu, Split Screen, or Table, and then Split Screen Table. But Control T is a lot quicker for you, so do that. So this tells me all of my factors. 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, and then it repeats 10 times 6, so that would be all of them. So I'm going to list all of my factors. So I have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 5, plus or minus 6. And then we have, let's see, plus or minus 10, plus or minus 12, plus or minus 15, plus or minus 20. Ooh, this one has a lot. Plus or minus 30, and plus or minus 60. So I am going to go ahead and make those a little smaller on my paper. Okay, but those are all of them. Now we're going to divide all those numbers by the leading coefficient factors. My leading coefficient goes with the highest degree. So my highest degree is 5. It's the number in front of that. So that is 4. So we have plus or minus 1, plus or minus 2, plus or minus 3. Nope, just kidding, 4. Okay, so now we're going to divide each of them. So I'm going to start by dividing every single number up top by 1. Every single number up top by 1. So here we go. We have 1 divided by 1, which gives us plus or minus 1. 2 divided by 1, which is plus or minus 2. 3 divided by 1, which is plus or minus 3. 4 divided by 1, which is plus or minus 4. 5 divided by 1, which is plus or minus 5. 6 divided by 1, which is plus or minus 6. 10 divided by 1, which is plus or minus 10. 12 divided by 1, which is plus or minus 12. 15 divided by 1, which is plus or minus 15. 20 divided by 1, which is plus or minus 20. 30 divided by 1, which is plus or minus 30. 60 divided by 1, which is plus or minus 60. Now we're going to repeat that with the number 2. So here we go. We have 1 divided by 2, which is plus or minus 1/2. 2 divided by 2, which is plus or minus 1. We already have that. 3 divided by 2, which is plus or minus 3/2. 4 divided by 2, which is plus or minus 2. We already have that. 5 divided by 2, which is plus or minus 5/2. 6 divided by 2, which is 3. We already have that. 10 divided by 2, which is 5. We already have that. 12 divided by 2, which is 6. We already have that. 15 divided by 2 is plus or minus 15 over 2. 20 divided by 2 is plus or minus 10. We already have that. 30 divided by 2 is 15. We already have that. And 60 divided by 2 is 30, and we already have that. Now we're going to repeat that process with 4. So 1 divided by 4 is plus or minus 1/4. 2 divided by 4 simplifies to 1/2. We already have that. 3 divided by 4 is plus or minus 3/4. 4 divided by 4 is plus or minus 1. We already have that. 5 divided by 4, which is plus or minus 5/4. 6 divided by 4, which is simplifies to 3 over 2. We already have 3 over 2. 10 divided by 4 simplifies to 5/2. We have 5/2. 12 divided by 4, which is plus or minus 3. We have that. 15 divided by 4 would be plus or minus 15 over 4. 20 divided by 4, which is 20 divided by 4, which is 5. We already have 5. 30 divided by 4 simplifies to 15 over 2, and we have that. 60 divided by 4 simplifies to 15, and we have that. So these are all the factors. This one had a whole bunch of them, but notice how when there was duplicates, we didn't take our time to rewrite them because we already had them. Okay? So, here we go. Why don't you go ahead and try this one and check your answers with the work that is provided for you in the completed review. Okay, let's go ahead and go to number 9. Using the leading coefficient test, determine the end behavior of the given polynomial functions and match the polynomial functions with its graph. So, here we go. We're just going to start with doing the end behavior and what it should look like. So, we start with a degree of 5, which is odd. Okay, so since it's odd, it's either going to go up and down or down and up. Okay, my leading coefficient is negative, so therefore my right side has to go down, so it's going to be this one. Okay, so we're looking for a graph that starts on the left side going up and ends on the right side going down. Starts on the left side going up, ends on the right side going down. That to me looks like answer choice A. Okay, let's look at the next one. We got x minus 4 squared plus 1. So the degree is going to be a degree of 2, which means it's even. So they're either both going up or they're both going down. Okay, the leading coefficient looks like it's going to be positive because there's nothing in front of that, which means they're both going up. So if we look at our answer choices, that would be answer choice D. Looking at number 3, f of x, we have a degree of 4, which is even. So they're either both going up or they're both going down. Okay, I see that my degree or my leading coefficient is negative, which means they're both going down. So looking at my answer choices, that would be answer choice C. Number 4, okay, I see that my degree is 3, which means that it's either going up and then down or down and then up. Okay, my leading coefficient of this one is positive, which means my right side's going up, so it's going to be this one, which looks like it's answer choice B. Okay, you could also graph all of these and match the graphs, the equations to the graphs that way. Okay, so if you're not in honors, you're done with the review from here. If you're in honors, you're going to listen up for the last 2 examples. Okay, find a third degree polynomial with real coefficients that satisfies f of negative 2 equals 522 and has 4 and 5i as some of its zeros. Now, I'm going to show you how you can do this using the calculator. So what we're going to do is we're going to graph the answer choices and look to see which ones has the zeros of 4 and if it goes through the point negative 2, 522. So we're going to go to our graph. We're going to go to a new document. No, we don't want to save. Add a graph. We're going to graph answer choice A. Negative 3x squared, or 3x cubed, plus 12x squared, plus 75x, minus 300. I hit enter. I don't care what it looks like. All I care about is the zeros. So Control T. Okay. I want to know that 4 is a 0. So this does have 4 as a 0. Perfect. Okay. And then I want to see if it goes through negative 2, 522. Negative 2 goes through negative 378. That is not what I want. So I can go ahead and mark that answer choice off. Now I'm going to repeat that exact same process with letter B. So I go to my graph. I get a new document. No, I don't want to save. Add a new graph. I'm going to type in negative 3x cubed plus 12x squared minus 75x plus 300. Enter. Control T for my table. I look at 4. It does have a 0 at 4. Now I need to see if it has the point negative 2, 522. Negative 2 goes through the point 522. Therefore, that's my answer, and we're done. Okay, so we don't have to go through all that work, but it is nice to show you how to do it by hand. Okay, number 11. The formula for the number of games to be played in a dodgeball league where each game is to play each other twice is n equals x squared minus 2x, where x is the number of teams in the league and n is the number of games to be played. If a league wants to limit the games to be a total of 224 games, how many teams can be in the league? So what we're going to do is we want to limit, the number of games to 224. Well, it says n is the number of games to be played, which means we need to replace the n in the equation with 224. So we have 224 equals x squared minus 2x. I'm going to move the 224 over to the other side. That way I can have it set equal to 0. So I'm going to subtract 224. So I get 0 equals x squared minus 2x minus 224. Now I can go ahead and graph it and find the zeros. Okay, we're going to graph it and find the zeros. So go back to our graph, new document. No, we don't want to save. Add a new graph. We're going to graph x squared minus 2x minus 224. We press enter. All we care about is the zeros, so I'm just going to menu 5, 1. Okay, it looked like it didn't have anything. It does. Now, if we're talking about number of games, okay, so let me move up a little bit so we can see. Okay, you're going to hit the left and right arrows, but if we're talking about number of games, can I play a negative number of games? Okay, meaning can I play a negative 14 games? No. So that answer is not a realistic answer. We only want the positive number of games, which is positive 16. So how many teams can be in the league? Sorry, I was talking the wrong thing. How many teams can be in the league? It's 16. We cannot have negative 14 teams, okay, because we wouldn't have a league then. So there's 16 teams in the league. So 16 teams in the league. And that would be it. So if you have any questions, please make sure you send me an email. I'll be glad to help you out. Or ask me in class so I can help you out before the test. Have a great day and good luck on your test.